This video is about stationary points and classifying them into maxima, minima and points of inflection. Stationary points are defined as when the first derivative of a curve is equal to 0. They are also commonly known as turning points. Classifying stationary points is a very useful technique in applied maths because it allows us to find the maximum or minimum value of a quantity. We are going to look at some graphical methods of classification as well as the second derivative test. If you would like some more information about the second derivative test before watching this video, we encourage you to look at the maxima, minima and points of inflection content on our differentiation webpage. Briefly, we know that at a stationary point, the first derivative is always 0. We can use the second derivative to classify the stationary point. If the second derivative is positive, we have a minimum. If it's negative, we have a maximum. And if it's equal to 0, then the test is inconclusive. The graph on the left is y equals x squared, and on the right is the graph of its gradient, dy by dx equals 2x. We get this by differentiating x squared. On the left, x squared is decreasing, so we have a negative gradient, which corresponds to the graph of the gradient being negative for negative values of x. At x equals 0, we have a stationary point, which corresponds to when the graph of the gradient crosses the x-axis. On the right, x squared is increasing, so we have a positive gradient, which corresponds to when the graph of the gradient is positive for positive values of x. Now we're going to look at the second derivative. As the second derivative is positive, this means that the gradient is increasing about the stationary point, so this must be a minimum. This second example is of a local maximum. The graph on the left is y equals minus x squared, and on the right is the graph of its gradient, dy by dx equals minus 2x, which we get by differentiating minus x squared. On the left at the stationary point, minus x squared is increasing, so we have a positive gradient, which corresponds to the graph of the gradient being positive for negative values of x. At x equals 0, we have the stationary point on y equals minus x squared, which corresponds to where the gradient graph crosses the x-axis. On the right of the stationary point, minus x squared is decreasing, so we have a negative gradient, which corresponds to when the graph of the gradient is negative for positive values of x. Now we're going to look at the second derivative, which is minus 2, which is negative. This means that the gradient is decreasing about the stationary point, so it must be a maximum. Now let's look at an example of where the second derivative test fails. On the left we have the graph of y equals x cubed, and its corresponding gradient, its graph, is on the right, dy by dx equals 3x squared. On the left of the stationary point, x cubed is increasing, which means that the gradient is positive, which corresponds to the graph of the gradient being positive for negative values of x. At x equals 0, we have a stationary point, which corresponds to when the graph of the gradient touches the x-axis. On the right of the stationary point, x cubed is still increasing, which means that the gradient is still positive, which corresponds to the graph of the gradient being positive for positive values of x. Now looking at the second derivative test, we can see that when we substitute in the x-ordinate of the stationary point, we get 0. This means that the test is inconclusive. The second derivative is always 0 at our point of inflection, so why is the second derivative test inconclusive? It's because there are some special cases where maxima and minima can also have a second derivative that equals 0. Here's an example. Y equals x to the power of 4 has a minimum at x equals 0. If we calculate the second derivative for this curve, we get 0. This means that we always have to use an alternative method to classify points of inflection. If you want to learn more about how to classify points of inflection, we encourage you to watch the video about them on our differentiation webpage. In this video, we have used graphical methods to understand how to classify stationary points. We have also shown how to classify maxima and minima using the second derivative test, and covered an example of when the second derivative test is inconclusive. If you would like some more worked examples, practice problems, or example applications, we encourage you to have a look at the maxima, minima, and points of inflection content on our differentiation webpage. Thanks for watching.